Okay. I'm kidding. All right, so 9.2 is reflections. And the first thing that we're going to talk about with reflections it's called opposite orientation. Okay, so this line right here is a line that we're going to reflect over. You've maybe heard of it as a line of symmetry before, same idea. This is a line of reflection. If I reflect this triangle, so this is triangle HOG, if I reflect it over that line, I will get H prime over here. I'll get an O prime over here somewhere. And my G prime is actually the same point that it started as. Here's what you need to see with reflections. With translations, everything was the same direction, right? You just took something and you slid it to a new spot, but when you named it, you went in the same direction. With a reflection, it's opposite orientation, which means however you name the first one, so in this case, HOG, we are going clockwise. That means that when we name the reflection, we will be going counterclockwise. Okay. Yes, you'll still match the corresponding parts, but now it will go in the opposite direction when you name it. So that's what we're doing for this first part. It says, notice when you reflect a figure, the shapes have opposite orientation, is what this first blank is called. Okay, opposite orientation. And two figures have opposite orientations if the corresponding vertices of the pre-image and image are read in opposite directions. So clockwise versus counterclockwise type of thing. Okay, so this is opposite directions. All right. So some things to know when it comes to reflections here. A reflection is always going to go across some line, which we call the line of reflection. Like I said before, you've maybe heard of it as a line of symmetry. It's the same idea, a line of reflection. But any reflection that has this line of reflection has these properties, okay? Number one, if a point A is on line M, so it's on the line, then the image of A, right, A being the pre-image, A prime being the image, is itself. Okay, which we typically call A prime. But if you look up here at our picture, G and G prime, because the point is on the line of reflection, it's exactly the same point. So if the point is on the line of reflection, it will be the exact same point for both of your figures. Okay? If point B, so they're just picking any random point, we don't have a B, but if point B is not on the line, then M, the line of reflection, is the perpendicular bisector of the segment. Okay, here's what we mean by that. Actually, let's just look up here. What they're saying is, if I have this, we'll call it H and H prime up here. I have these 2 points that are not on my line of reflection. If I draw that line in, this purple line, my line of reflection, is the perpendicular bisector of that segment, H prime. So that means that this distance has to be the same as this distance, and this is going to form a 90-degree angle every single time. Okay, you could do it up here as well. If we connect these, this distance is the same as that distance, and this will be perpendicular. Okay, so you're going to see a lot of perpendiculars with, when you draw reflections, you'll have a lot of perpendicular lines. How are we doing so far? I'm almost done with the words. We'll move on to the things pretty quick. last thing, these three things are also true of reflections. Just like we said yesterday, do you remember that 2-word phrase that we used? A rigid motion, right? What is a rigid motion?
It's like a slide.
A slide is a rigid motion. A reflection is a rigid motion. What is it?
It's like you're moving the figure, but
It's the exact same figure. They're congruent figures, right? Essentially is what it is. But the way that we said it to show what we're talking about is reflections will also preserve distance. And what was the other thing they preserved? Do you remember?
Size.
They do preserve size and shape, but because of distance and angle measure. Okay, so in other words, what we're saying here is a reflection is a rigid motion. That's the definition of a rigid motion. Okay, and then the last thing, and this is just kind of a duh point, but maps each point of the pre-image to exactly one point of an image. So when you do a reflection, whatever point is on this side, you have exactly one point that matches up with it on this side. Okay? Okay, here's what we're going to do with this. Example 1. Point F has the coordinates 2, 6. So 2, 6 would be right here. And they say that is point F. Okay. The question is, what are the coordinates of a reflection over y equals 3 of that point? Can I help you find someone? Who? Yeah, back here.
Hey, can I get your registration form?
Yeah, I couldn't find it. I thought it was
Okay, so our line here, y equals 3. What type of line is that? It's not vertical. It's horizontal, okay? But that's where most people make mistakes on this. So y equals, here's the little trick that I always tell people. If you take the letter y and you flip it 180 degrees, doesn't it look kind of like an H, right? So whenever it's y equals, you need to think of a horizontal line. Whenever it's x equals, think of the letter x. It's pretty much a V with an upside down V for vertical, right? So x equals will always be a vertical line. Y equals will always be a horizontal line, okay? So if they're saying here, the reflection over the line y equals 3 of f, that's what we need to do. We need to reflect it over that line. So just so you're clear, because later on you're going to look at this and go, what does that mean again? This is saying the reflection over the line y equals 3 of point F. Okay, capital R is reflection, just like the capital T was translation. Okay, so if we're going to do this, the line y equals 3, you're looking for where does y always equal 3? Well, I know y is 3 here, and I know y is 3 here. 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. That's all y as 3, right? So my line, y equals 3, is this line, a horizontal line through the value of 3. Okay, now we're going to do a reflection over that line. Right now, point F, remember we said we have to go perpendicular. So if we're horizontal, we need to go vertical to get to our new point. So we're at F, we go 1, 2, 3 to get to the line. That means I need to go 3 more. Think of it as if I fold my paper on that red line. Where would I end up? 1, 2, 3. Point F would end up right here as F prime. Okay, so when they say what are the coordinates, you would end up at the point 2, 0. Most of the time I just have you graph it. You don't have to tell me the name of the point. You can just graph the point for me. Real quick, while I have a little bit of space on this one, what if I said a reflection over the line, we'll say x equals -1 for point G. Okay, so I'm going to put G right here. What's the line x equals -1? What kind of line is that?
Vertical.
That one's vertical. So you would go at -1, a vertical line here. Okay, if I want to reflect over that, where am I moving? I want to stay perpendicular to that line.
Right. So
You're going to move to the right. You're going to move straight right. Okay, so if I reflect over that line, 1, 2, I need to go 2 more, 1, 2, and that would be my G prime. Okay, does that make sense? So just remember, this is vertical. Y equals is horizontal. That is probably the place where people make the most mistakes in this lesson. Okay? All right. Now we're going to get a little fancier with it. Instead of just flipping a point over a line, we're going to flip an entire triangle. But here's the beautiful thing. It sounds fancy. You do the exact same thing. You just do it 3 times instead of 1 time. Okay? And then you draw a triangle in. So we are going to draw this triangle. So start by plotting those points. -4, 3, 1, 2, 3, 4, 1, 2, 3. So here's my x. 2, 6. Puts us here. That's my y. And then -1, -8 kind of goes off our graph, but we're going to use this shaded little piece as our z. So you start with this triangle. Can you tell me how this reads? What's the green shaded there? How would you say that?
the reflection is over the
Right.
that line.
So you're saying it's a reflection over the x-axis of triangle XYZ. Now, I love it when they say x-axis, but sometimes they won't. Sometimes they will call the x-axis an equation of a line instead. Just keep in mind the x-axis is actually the line y equals 0, right? It's a horizontal line, that's y equals. So keep that in mind. Y equals 0 is the x-axis. X equals 0 is the y-axis, so be careful with that. Okay, so if we're going to reflect over the x-axis, that's this line here, don't try to flip an entire triangle at once. Pick one point. So let's start with x. If I am here for x, where do I need to go to find x prime?
Down.
You need to go down. So right now you're 3 above the line. You need to go 3 below the line. That would be x prime. Okay? Then we want y prime. Where do we go? You're going to go down again. You're up above the line 6 units. You need to go 6 below. 1, 2, 3, 4, 5, 6. And I don't need the little bumpies. I'm just doing that so you can see where I'm moving. So this would be y prime. And then z prime. Now, this is probably the one where people make the mistake because they think, oh, I've been moving down all this time. I'm just going to move down again for z. But that does not reflect, right? If we're going to reflect over a line, we need to go to the opposite side of the line. Well, right now, we are 1, 2, 3, 4, 5, 6, 7, 8 below the line. So you need to go 8 above the line. 1, 2, 3, 4, 5, 6, 7, 8. So your z prime is up here, and that would make this your triangle. Okay, which gets a little hectic because you're overlapping. That's why I say 1 point at a time. Don't try to flip the entire triangle at one time. Flip 1 point at a time. So when they ask you what your coordinates are, x prime is at the point -3. Nope, that's a -4. Sorry. -4, positive.
Negative.
Oh, -3. I'm looking at the wrong triangle. This is the blue triangle. Sorry. -4, -3. Your y prime is at 2, -6. And your z prime is at -1, +8. Okay, questions on that? All right. Next thing. Example 3 here. It says describe triangle 2 using a reflection rule. So you're going to write something that looks something like this. Now it's going to be a little different because we don't have letters, we just have numbers. But that idea, okay? So what letter represents a reflection? Translation was T. What's a reflection? Capital R, okay? Capital R, because tomorrow, or Monday, we're going to do a lowercase r. So a capital R, reflection. And now your job is to figure out where is 2 being reflected. So what line are we reflecting over? K, right. So we're going to say a reflection over line K of triangle 2 will map onto what triangle? If I reflect 2 over K, I end up where? Triangle 4. Okay, so tell me the line you're reflecting over, the triangle you're reflecting, and what it becomes. Those 3 things, okay? And then the capital R to tell me what you're doing. A reflection, a translation, what is it? Okay, questions on that? Okay, this last part, I don't even care if you don't take notes on it. I'm never going to ask you to do something like this again. I just want you to understand where they're coming from with a reflection, okay? Your first step, they tell you all this information, which is just telling you each point is being reflected over line T, okay? So that all goes here, which is given. What they're asking you to prove is that you have an isosceles triangle. Well, if you look at your next step, this says a reflection over T of GH is equal to GJ. So they're telling you these 2 segments are congruent. The reason we know that is they told us both the points are reflected. And we said earlier, reflections preserve distance, right? So that's why we know the segments are congruent, because the reflections always preserve distance. Okay, which means if they are congruent, which we marked here, how do we know that's an isosceles triangle?
Because it's obvious.
Because it's obvious. It's got the tickies because that's the definition of an isosceles triangle, right? 2 congruent sides. So definition of an isosceles triangle tells us then those have to be isosceles, or that triangle has to be isosceles. Okay, any questions on that? All right.